Hello and welcome back to this course, covering the exam topics for the JNCIS-SP certification. In this section of the course, we're reviewing Layer 2 switching and VLANs, where we're covering Layer 2 switching mechanisms and Ethernet switching configurations in JNCIS. In this lesson, we'll be taking a look at the other three bridging mechanisms: flooding, filtering, and aging. As we learned in the last lecture, a switch's primary purpose in life is to learn where MAC addresses live and then forward frames appropriately based on the destination MAC address by looking up the destination in the bridging table. In this video, we'll be covering the other ancillary operations required to support the primary functions of learning and forwarding. So, without further ado, let's jump on in. First up, we're looking at the flooding mechanism. A switch uses the flooding mechanism to forward a special classification of traffic called BUM traffic. BUM stands for broadcast, unknown unicast, and multicast. For a review of what the technical differences are of broadcast, unicast, and multicast traffic, I recommend checking out the Networking Fundamentals section of the JNCIA JNCIS course I also have on this platform. Though, here, I'll give a quick refresher. Broadcast frames have a destination MAC address of all Fs. These are frames destined for all nodes on a broadcast domain. Some protocols require broadcasts to locate an appropriate node, such as ARP. ARP, or the Address Resolution Protocol, is one such protocol where broadcast frames are used to locate a node which is configured to respond on a particular IP address, and request that node's MAC address. Unknown unicast frames, however, are not a special classification of traffic. They are simply regular unicast frames. These frames, however, have a destination MAC address which does not have an entry in the switch's bridging table. Since the switch is not aware of which specific port to forward the frames out of to reach the destination, these frames are treated like broadcasts and flooded out all ports to ensure the frame reaches its destination. As we see in our bridging table here, unknown unicast destinations are flooded out all interfaces. It should be noted, though, that you will not actually see a catch-all entry in an actual bridging table like this. This entry is only for illustration purposes. Finally, multicast frames have a destination MAC address in the multicast range. Multicast, by definition, is a type of traffic which has a one-to-many behavior. Protocols may be configured to allow end devices to communicate what multicast groups they are interested in with a switch. However, without those protocols configured, the switch handles multicast frames the same way as broadcast and unknown unicast, in that it simply floods the multicast frames to ensure they reach the desired destination. So that's the flooding mechanism. Now let's take a look at the filtering mechanism. The filtering mechanism is used to drop traffic, which should not be forwarded. A switch will filter traffic to ensure only frames associated with the port or broadcast domain are accepted and forwarded. As we learned previously, a VLAN represents a broadcast domain, where a broadcast domain consists of all ports and links that a broadcast frame would be flooded to. If a frame is received on a port and tagged with a different VLAN than the port is a member of, then the switch will filter that frame by default. This is essentially saying if the frame is a member of a different broadcast domain than the port it was received on, then it will be filtered. Additionally, if a frame is received by the switch and the destination MAC address is known to be reached on the same port the frame was received on, then the switch will also filter that frame by default. In our illustration below, we see how a situation like this could occur. If multiple devices are connected via a hub, and a frame is sent from and destined to one of the devices connected by that hub, the switch will also see this frame, because it too is connected to the hub. Since the destination MAC address is known by the switch to live on the same port the frame was received on, the frame will be filtered and dropped. Now that we know how the flooding and filtering mechanisms participate in bridging, let's take a look at the last mechanism, aging. The aging mechanism is used to ensure the information stored in the bridging table is fresh and relevant. This makes sure the switch does not continue forwarding frames out an interface where a destination MAC address no longer lives. The aging mechanism works by resetting a countdown timer every time the switch sees an ingress frame sourcing from the MAC address. By default, Junos switches will keep entries in the bridging table for 300 seconds, or 5 minutes, before removing the entry if no frames sourcing from that address are seen. This default aging time may be changed and configured by the network administrator using this command. Note that this command will affect the global bridging table aging mechanism, rather than some subset of interfaces or VLANs. Now that we've reviewed all of the bridging mechanisms at play, let's work an exercise to put our new skills into practice. In this exercise, we have the topology presented, with 4 users connected to the LAN: John, Rachel, Allison, and Ben. Allison and Ben are connected to a hub at their desk, which is then connected to the switch that the remaining users are connected to. The switch's bridging table is shown here, and as expected, Allison and Ben's MAC addresses are showing to be connected on the same interface. Allison sends a frame with the destination MAC address for John. In this topology, who will receive that frame? Recall that in a single collision domain, all connected devices will receive data transmitted by any other device in the collision domain. Also recall that a hub connects multiple ports into a single collision domain. Since Ben is connected to the same hub as Allison, he is in the same collision domain as Allison, and he will receive that frame even though it's not destined for his MAC address. So his device will likely ignore the frame. When the switch receives the frame, it will look up the destination MAC address in the bridging table to determine what port to forward the frame to. However, we see that John's MAC address is not present in the bridging table. This frame is therefore classified as unknown unicast and will be flooded out all ports to ensure John receives the frame. This means Rachel and John will both receive the frame as well. So, in this exercise, all connected users end up receiving the frame. Thank you for working through that with me. I hope that this lesson has been informative for you, and I would like to thank you for viewing.